let's do null checks. So how are we going to print this thing out? Let's say we have and sometimes it helps to, if you have a whiteboard going here, I feel like it makes, okay, what is going on? What is happening, dude? Okay, if you have a whiteboard or you have a piece of paper, it sometimes helps to make it clear, right? If I had A, B, C, D, E, right, or something like that. So A is going to say, print out my left subtree. Okay. B is going to say, well, my left subtree is not null. Print out my left subtree. C is going to say, my left subtree is null. I'm going to print myself out. My right subtree is null. Return. Okay. So we've just got to do our null checks in a smart way. So maybe I misled you with my pseudocode, but it's okay. The idea was, my heart was in the right place, people. All right, so let's do this real quickly. So the null check would be if left shark equals null, right? Then so if left shark's not equal to null, then we can print out the left subtree recursively. So we go left.print, okay? And if otherwise, we're gonna print ourselves out, right? So how do we print ourselves out? We go system.out.println, and then our data, right? We can print out our student ID. You can print out your name too. I don't really care. We'll just print out the student ID for now. So we could say data.hashcode. So it'll print data.hashcode, and then we can print like a thing like that. Okay. And so it prints out the left one, right? And then it prints out our solves. So it left print, and then it prints out our solves, and then it prints out the right subtree. Okay, so let's print out the right subtree. And what's that going to be? Well, it's just going to be the other way. If right does not equal null, then we can say right.print. Otherwise, we're done. And so think about it. Left will print out itself, right? And the right one will eventually print out itself, okay? And they'll just keep on trying to get otherwise it'll keep on recursing. Now, I am in parentheses trouble. And why am I in parentheses trouble? I think I lost the curly brace down here. So let's get that back. Okay. Now, we should be able to kind of test this out. I don't know if it's going to work, but it'll be fun, and you'll see how the sausage is made. So the first thing we're going to do is we're going to make a binary search tree. Okay. So we can say BST my tree. Why isn't it? There we go. My tree. BST student, right? It's a student. My tree equals new BST. Okay. And now we can say my tree dot insert A, which is 7005. My tree dot insert B, which is 7003, and then we got to do one to the right. So my tree dot insert G, okay, and then my tree dot print. Now let's see what happens. All right, so we're expecting it to be B 7003, 7005, and then 7006. And if it's not, then we'll go back to the drawing board. And I won't re-record this. I'm going to make a promise to you. Usually I re-record them if something goes wrong, but I won't this time. If I made a mistake, if you see a mistake right now, pause the video, make a grand declaration if you see a mistake. I don't think I've ever, well, let's find out. There's a first time for everything. So yeah, here we go. I don't know. It looks good. Looks good. You know what I'm going to do? I'm going to make a few changes. I am going to, instead of saying system.out.println, I'm just going to make it a system.out.print. That's actually the only change I'm going to do. Not so bad. Not so bad. All right. So hopefully this makes sense to you. By the way, look at how nice and kind of logical this is, right? My left subtree is less than me, so print that out. All of you print your stuff out, right? My right subtree is greater than me, so I'll print myself out, and then I'll print out my right subtree. This is called in-order traversal, okay? In-order traversal. All right. See you next video. Or should I set? Are we doing a thing? No. I'll see you next video.